Hello students, how are you all? I hope you all are fine. See here what is written, properties of determinants. Okay, so today we are going to discuss about the property of determinants. Before this video we had discussed about the how you will find the how you solve the linear equation in three ways by using matrix. Okay, now see here what properties are the determinants here. Here nine properties are written. One, reflection property, all zero property, proportionality repetition property, switching property, scalar multiple property, sum property, property of invariance, factor property, angular property. Okay. So we will discuss each property one by one. Okay. So let us start from first. What is reflection property? Reflection property. Reflection property means if we interchange, if we interchange, okay, or if we change row into column or column into row. Okay, suppose a matrix is there, a b c d e f g h I, suppose. Okay, so if we write this matrix as a b c a b c and this one here d d g. Suppose we are interchanging one row and column. Okay, so here no effect will be there. Here no effect will be there. Okay, so it means no effect on determined value. No effect on determinant value. Okay, means determinant will be same. Determinant will be same. Okay, if we change row into column or column into row, so no effect will be there. Determinant value will be same. Okay, so this one is the reflection property. Now this here the second property. Second property is what? Second property is what? All zero property. All zero property. All zero property means if any row or column, if any row or column contains all elements, contains all elements zero. Okay, contains all elements zero. Then determinant determinant will be zero. Okay, for example, suppose we have 0 0 0 a b c d e f. Okay, or 0 0 0 a b c d e f. Suppose we have this matrix. Okay, or a b c 0 0 0 d e f. Okay, or you can say a b c 0 0 0 d e f. See here. Okay, if you see in a matrix any row or column contains all elements zero, then determinant of that matrix will be zero. Okay, why zero? When you will expand, then you will multiply zero with the minus, then it becomes zero. So determinant will be zero. See here, this is the all zero property. Okay, so I hope you have understood these two. Now let us see the third one. Now let us see the third one. Third one is what? Proportionality repetition property. Proportionality or repetition property. Repetition property. Okay, so proportionality repetition property means if any two rows or if any if any two rows or two column have have same element, have same element, okay, have same element, then determinant then determinant then determinant of matrix will be zero, okay, will be zero if in a matrix, okay, any two rows or column have same element, okay. For example, suppose we have a matrix a b c a b c d e f. So in this you can say two rows have same element, or a b c a b c d e f. In this you can see both column have same element, then their determinant will be 0, then their determinant will be 0. How it will be 0? When you will subtract first row from the second row, okay, and write as first row, then all element become 0, okay. So suppose here you are write down r1 such that r1 minus r2. So how you will write? 0 0 0 a b c will come and d e f will come, okay. If you are writing r1 such that the r1 minus r2, then this will come. Or you are writing c1 such that c1 minus c2, then in this all element become 0 0 0 0 a b c and d e f will come. So see here, by the zero property it will become 0. So see, if any two row or two column have same element, then determinant will be 0, okay. So I hope you have understood this one. Now let us see the next one. Next one is what? Switching property. Okay. Next one is what? Switching property. Fourth one, switching property. Switching property means if we interchange, if we interchange any two row, if any interchange any two rows or two columns, two columns, then the determinant, then the determinant value sign change gets changed, okay. Suppose for example we have a b c d e f, a b c d e f g h I, okay. Suppose we have matrix a b c d e f g h I, then suppose if we are writing r1 interchange with r2, r1 interchange with r2, it means in r2 r1 will come, in r1 r2 will come, r2 element will come. So now this can be written as def abc ghi, okay. Then determinant value will be represented by minus, okay, will be represented by minus, okay. If again you interchange, if you again interchange, then it will become plus. Suppose you are writing r2 r3, r2 r3, then what you will get? Here write down def ghi abc, okay. Now again plus value will be there, okay. So switching property means if you are interchanging any two rows or two columns, then determine values sign get change, okay. See the switching property, okay. Now let us see the scalar multiple property. Scalar multiple property. scalar multiple property. Okay, so next one is fifth one, scalar multiple property. Scalar multiple property says that if you if we multiply matrix by a scalar or constant value, then the then the determinant determinant value gets multiplied multiplied by scalar or constant value. Okay, suppose for example a b c d e f g h I matrix is there. Okay, and you are multiplying by 2. Okay, then determinant of this matrix get multiplied by 2. Okay, will be the answer. So this is the scalar multiple property. If you are multiplying any matrix by any constant or scalar, then their determinant value of given matrix get multiplied by that scalar. Okay, so this is the switching property. Now let us see the sum property. Okay, suppose a matrix. So sixth one, property. Sum property means suppose we have a plus b c d e plus f h I j plus j k l m. Suppose this matrix you have. Okay, suppose this matrix you have some property. Suppose we have this matrix. Now this can be written as a c d e h I j l m plus h c d f h I k l m. So this matrix can be written as the sum of two matrices. Okay, sum of two matrices. It means if any row or column, if any row or column have element as sum of two or three. Okay, number or constant, number or variable. Okay, here write down constant. Then given matrix can be written as sum of two matrix. Can be written as sum of two matrix. See here. So this matrix in this column is represented by sum of two variables. Then these can be separated by. In this way you can write. So this is called the sum property. Okay. Now we will learn some properties of invariance. Okay, properties of invariance. Properties of invariance. Okay, properties of invariance means seventh one. Property of invariance. Properties of invariance means suppose suppose we have A comma A B C D E F G H I. Suppose we have this matrix. Okay. Now this can be matrix. This matrix can be can be written as A plus alpha beta alpha D plus beta C D plus alpha alpha E plus beta F G plus alpha H plus beta I, and here B C E F H I C F. If any matrix you have, to, then you can write given matrix as this one. Okay, means here we are converting column first. So C1 can be written as C1 plus C1 plus alpha C2 plus beta C3 can be written, or you can write R1 as R1 plus alpha C2 alpha R2 plus beta R3. Okay, so you can write if you want to, for finding the, if you are suppose that if you see that by taking the sum of all three becoming zero. Okay, suppose taking the sum of all the things becoming zero, so you can write. Okay, so in this, suppose that you have one, uh, suppose that you have 3 minus 1 minus 2, suppose. Okay, and here 4 minus 2 is there, and suppose here 5 minus 3 minus 2 is there. Okay, so by taking sum of all the element of this row, mean this column. Okay, so 3 minus 2 0 become, 4 minus 2 minus 2 0 become, 5 minus 2 minus 3 0. So if you are applying this property here, okay, so what will come? 0 0 0 will come here, minus 1 minus 2 minus 3 will come, minus 2 minus 2 minus 2 will come. It means this determinant will become 0. Okay, so you can apply property of invariance for calculating the value of determinant as fast as possible. Okay, so this is the property of invariance. Let us see. Now let us see. Let us see factor property. 8.1 factor property. Factor property. Factor property. So factor property means, suppose if we put x is equal to a, x is equal to a, and this if we get determinant value 0, determinant value 0 on putting x is equal to a, then x minus a is a factor of given given matrix, you can say, given matrix, you can say. Okay, for example, suppose that if you have x minus 2, x minus 2, okay, and x minus 2, and here it is 1 2 3 4 5 6, suppose you have. Okay, so here you can, if we put x is equal to 2, then this element becomes 0 0 0 0 will come, 1 2 3 will come, 4 5 6 will come. Okay, it means determinant value will be 0. It means x minus 2 is a factor of the given element. Okay, given matrix, you can say this. Okay, so this is the factor property. Now let us see the triangular property. Now let us see the triangular property. Now ninth one, triangular property. Okay, triangular property means if if elements elements above or below the main diagonal of matrix, diagonal element of matrix of matrix of matrix are zero. Okay, suppose that we have a matrix A B C D E F. Suppose we have 0 0 0 is there. See, this is the main diagonal. Okay, suppose if we are writing main diagonal, how you will write? A B C you will write. Now here suppose the 1 2 3 is written. Okay, now this one and this one is 0, or you can say A B C 1 0 0, sorry, 1 2 3 here written, and here 0 0 0 is written. Okay, see, so this is the main diagonal. Okay, and below the main diagonal elements are 0. In this, below the main diagonal elements are 0. Then determinant, then determinant 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 of matrix is product product of diagonal element. Product of diagonal element. Okay, triangular property means if the element above or below main diagonal element are 0, then determinant of matrix will be product of 0. So see here, what elements are written in the main diagonal? A B C. It means determinant will be A B C, product of diagonal element. If 1 2 3 is written, then 1 into 2 into 3 means 6 will be the determinant. Okay, so in this way you can find determinant of a given matrix if that matrix following the triangular property. Okay, so I hope you have understood all the property related to the determinants. If you have any doubt in any property, then you can ask me, leave comment in comment box, and if you are facing any problem, any question, then take pick of that question, send me at my WhatsApp number. This is my WhatsApp number I am leaving here. Okay, I will make video and to clear your doubts. Okay, so till now, thank you, and wait for the next video. In next video, we will solve some question related to the properties by using the properties of determinants. Okay, thank you. Have a nice day.